In this video, we're going to talk about ionic bonds, and if you have not already watched my videos on the organization of an atom and on what the periodic table tells us about an element, I want you to go ahead and pause this video and go watch those videos first, and you can find the link to those videos in the description for this video. I also do not have the space to put a periodic table on my screen, so I'm going to recommend that you either print off a copy of the periodic table or that you open up the periodic table on a new tab on your computer to use as a reference. Alright, so what is an ionic bond? So in an ionic bond, one atom is going to accept electrons from another atom, or it is going to donate electrons to another atom. Because of this, each atom involved is going to have a charge. Most of the atoms we've talked about so far are neutral atoms. They have the same number of protons and electrons. The positive and negative charges balance each other out. But if an atom is giving away electrons or is gaining electrons, it is going to have a greater negative charge or a greater positive charge. Opposite charges are going to attract and cause these atoms to stick together, and this is an ionic bond. So we have two types of ions. We have cations and we have anions. A cation is going to have a positive charge, and I remember this, that the T here looks like a positive sign. So cations have a positive charge. Anions are going to have a negative charge, and I remember that this N right here, N is for negative, and the second letter in anions is an N. So anions have a negative charge. So let's look at some examples. So chlorine has an atomic number of 17. So in a neutral chlorine ion, we're going to have 17 protons and 17 electrons. These charges are going to balance each other out. So these 17 protons are going to be in the nucleus. This inner circle is representing our nucleus, and this outer circle is representing our valence shell. Chlorine is in the 7th column of the 3rd row of the periodic table, so it's going to have 7 electrons in its valence shell. And its valence shell is going to be its 3rd shell because it's in the 3rd row. So we have 2 full shells in here, and then this 3rd shell is going to have 7 electrons in it. For chlorine to have a full shell, it needs 8 electrons in its valence shell, because chlorine is in the 3rd row of the periodic table, and the 3rd row has 8 columns, so it needs 8 electrons to have a full 3rd shell. So chlorine, it could get rid of all 7 of its electrons here, or it could just gain 1 more electron. So if chlorine gains an electron, it will still have 17 protons. Chlorine will always have 17 protons, but it will have 18 electrons. So it will have 1 more electron than it has protons. So chlorine will have a negative charge. We're going to write that as Cl-. Chlorine has a negative charge, so it is an anion. Okay, now let's look at sodium. Sodium, if it is a neutral atom, it's going to have 11 protons, because it has an atomic number of 11, and it's going to have 11 electrons. So these 11 protons are going to be found in the nucleus. And sodium, it is in the 1st column of the 3rd row, so it's going to have 3 shells, and it's going to have 1 electron in its outermost shell, in its 3rd shell. It's going to be its valence shell, so it has 1 valence electron. So sodium is in the 3rd row, and the 3rd row of the periodic table has 8 columns. So for sodium to have a full 3rd shell, it would need to gain 7 more electrons. Or we could get rid of this 1 electron here, and then our 2nd shell would be the outermost shell, and that one is full. So sodium here is going to get rid of one of its electrons, and it might give it to an atom like chlorine. So now sodium here is going to have 11 protons. Sodium will always have 11 protons. That's what makes it sodium. But now it will have 10 electrons. So we have one more proton than we have electrons. So we're going to write this as Na+. Sodium is going to have a positive charge. Now, this sodium ion is going to be a cation because cations have a positive charge. So the sodium just gave an electron. It donated an electron to chlorine. Chlorine has accepted this electron. So we have a positive sodium ion, a negative chlorine ion, and these two ions might form an ionic bond. So in an ionic bond, we're always going to write the cation first. So we're going to write Na+, and we're going to add that to Cl-. And this is going to yield sodium chloride. Sodium chloride is table salt. So this sodium ion and this chlorine ion might form an ionic bond and make sodium chloride. And here we have written the positive charge and the negative charge. Remember, opposite charges attract each other. And this sodium ion is charged, this chlorine ion is charged, but sodium chloride together is not going to have a charge because this positive charge and this negative charge are going to balance each other out. Sodium donated donated an electron to chlorine, but we haven't actually gained or lost electrons from sodium chloride as a whole. It still has the same number of electrons as we started out with. All right, now let's look at another example. So let's look at calcium. Calcium has an atomic number of 20, so it's going to have 20 protons, and 20 electrons in a neutral atom. These 20 protons are going to be found in the nucleus, and calcium is in the 4th row in the 2nd column. So it's going to have 4 shells holding its electrons, 4 shells holding the electrons because it's in the 4th row, and 2 of these electrons are going to be in the 4th shell, in the valence shell. So we have 2 electrons here in the valence shell. Since calcium is in the 4th row, the 4th row of the periodic table has 18 columns. So we need to have 18 total electrons to have a full 4th shell. But calcium is going to just get rid of these 2 electrons here. It's going to give them away to another atom. And then its full shell will be its 3rd shell. Its 3rd shell is already full, and that will be its outer shell now. Okay, so now we have 20 protons, because calcium is always going to have 20 protons, and we just lost 2 electrons, so we're going to have 18 electrons. Now calcium is going to have 2 more protons than it has electrons, so we're going to write this as Ca2+. It has a double positive charge. And this is going to be a cation, because cations have a positive charge. All right, now let's look at one final example. Let's look at hydrogen. Hydrogen has an atomic number of 1, so it's going to have 1 proton and 1 electron in a neutral atom. This 1 proton is going to be here in the nucleus, and hydrogen is in the 1st row in the 1st column, so it only has 1 valence shell, 1 shell holding its electrons. This 1st shell is going to be its valence shell, and it has 1 valence electron. There are 2 columns in the 1st row of the periodic table, so for hydrogen to have a full shell, have a full first shell, it needs to have 2 electrons, so it can gain an electron, or we could just lose an electron, and then we would have 0 electrons. So it has 2 equally easy options here. It can lose an electron, or it can gain an electron. So if we lost an electron, we would have 1 proton, and we would have 0 electrons. So we would have H+. We just have a proton, and we have a positive charge on this hydrogen ion. So this would be a cation, a hydrogen cation. Or if we gained an electron, then we would have 1 proton and 2 electrons. So this would be H-. We have 1 more negative charge than we have positive charge. So H-. This would be a hydrogen anion. So hydrogen has 2 paths that it can follow here. All right, let's review what we've gone over. So an ionic bond is when one atom accepts electrons from another atom or donates electrons to another atom. Each atom will have a charge. We will have a positively charged ion, which is a cation. We will have a negatively charged ion, which is an anion. These opposite charges might attract each other and bind these 2 atoms together, and they will form an ionic bond.